All right, so we're going to go ahead and review distributive properties so that we can get ready to multiply polynomials. Okay, so we've added and subtracted them, we've named them, we've described them, we've done all that. So we need to review so that we can go ahead and multiply them. All right, so you've seen this. You've probably seen this since either 5th grade or sometime in middle school. Okay, when you have parentheses and you have a number or something outside the parentheses with no symbol in between, that means you're supposed to multiply. And you're supposed to multiply whatever's on the inside times all pieces that are on the, or rather, whatever's on the outside by all pieces that are on the inside. Okay. Not a big deal if it's just numbers, right? Because PEMDAS says do the parentheses first, and you would do 6 plus 1 and multiply it by -3, and you'd be good to go. It does work that -3 times 6 plus -3 times 1 is going to give you the same answer. It's going to give you -21. Some of you have already seen this done with variables, and some of you haven't, so no stress. We're going to go ahead and go back over this. This works the same way. Now, like I said, I know PEMDAS would tell us that we're supposed to do the parentheses first, but since we have a variable, right, something that stands for an unknown, we can't add x plus 1 in any real way other than writing it as x plus 1 because we don't know what x is. So we basically take and multiply the -3 on the outside by both pieces, right, whatever's on the inside, and you keep the operation that's on the inside with it. Okay, so this is -3 times x plus, because we are adding, -3 times 1. Okay, so you multiply each pair. So -3x is just -3 times x is written like that, right? No symbol in between. And then -3 times 1 is -3. So you can either write it as plus a -3, or since integers work this way, you can write it like that. All right, so let's try a couple more before we move up to the next step. Okay, so 5 times, because that's what that means when you have the parentheses, remember that it's multiplication, 5 times 2x minus 4. So that is a difference statement, right? A subtraction statement, and you're multiplying 5 times both pieces. So 5 times 2x minus, because that's what we are doing, 5 times 4. So that should be 10x minus 20. Okay, so same thing. 6x times 3 minus 6x times 4x. Now, this is where you need to remember a little bit about your exponent rules, is that when you are multiplying a variable, same variable, times another one of itself, you are adding the exponents together, right? So it's x times x is not 2x. That's when you're adding. X times x is now x squared. And I usually give kids a little bit to think about. What I normally tell them is if you're thinking about like measuring the area of a room, right? You get the length in feet and then you get the width in feet, right? So you're multiplying to find area, you're multiplying length times width. So you're multiplying feet times feet, right? You're multiplying two of the same variable or same measurement, right? And when we give area in feet, we talk about, okay, well, this room is 300 feet squared or 300 square feet. And the reason that you're doing that is because you are multiplying two of the same type of dimension, okay, feet and feet. So same thing when you're multiplying variables. Okay, so 6 times 3 is 18x. And then 6x times 4x, you multiply the coefficients. 6 times 6 is 24. And x times x is 24x squared. It's the same thing if you're multiplying volume. If you think about it, you're multiplying 3 of the same variables. And if you're multiplying x times x times x, you would get x to the third or x cubed. So it does work the same way as if you were just using it as a measurement. Okay, so another way to show multiplication, okay, is called an area model. Okay, and it's just exactly what I was talking about. You're basically finding the area of something with a specific length and width. Okay. All right, so when you set it up as what we call an area model, you would write 6x times 3 minus 4x. Okay, so this would be your width, and this would be your length. And you can actually flip it around the other way. It doesn't really matter as long as you're multiplying length times width or width times length. Okay, so this is what it would be looking like. So this is my width, and let me show you something. And this is my length. Well, in order to be able to multiply this, I have to split this into two separate pieces, right? So I have a 6x times a 3, and then I have a 6x times a negative 4x. Right? So you're basically getting different pieces. And I know y'all have done this before where you have found the area of like irregular rooms and you had to cut it into pieces, or you had to find, even ones that had like triangles and circles, and you had to cut it into pieces in order to be able to find the different areas and put it all together. It's the same thing. We're cutting what's in the parentheses into two pieces so that we can multiply them separately to find our overall area. So our overall area, it's the same as before, 18x minus 24x squared. Okay, so we'll try this one. This is where we start getting into what we're doing in algebra. Okay, so now I have two pieces that have variables. So we have two things that are unknown, right? They're both x. So now I'm going to tell you that your length is x minus 1 and your width is 2x plus 3. So now you have to split both of them. Okay, so your area model, right? If x minus 1 is your length and 2x plus 3, or 2x and a positive 3, is your width, your area model is now going to look like a square, right? Because you have to cut the x minus 1 into two pieces to work with, and the 2x plus 3 into two pieces to work with it, okay? And then you're going to multiply 4 times. This piece of the width times this piece of the length, this piece of the width times the other piece of the length. So 2x times x. Remember the squared because you're multiplying x times x. And then 2x times the negative 1. And then 3 times the x, because that's the other piece of the width times the first piece of the length. That's 3x. And then 3 times negative 1. You can also think of it like a multiplication table. If you ever used one, or a map, when you're reading a map, you go down one side and across the top, and you kind of put them together to find out what they're the pieces that goes together, right, on a multiplication table. It's the same thing here. You're multiplying the width, both pieces, times the length, both pieces, and you get 4 pieces total, which is what you should get. Okay, now the only thing is on this, when you go to multiply it, right, you have to make sure your answer is in standard form. So let's write out what we have here. We have 2x squared minus 2x, that's a positive 3x, and a negative 3. So those are the 4 pieces that I have. So let's put this into standard form to make sure that it is written as simplified as it can be. So that's 2x squared, right? And these are like terms because they both have a single x. So that's negative 2 plus 3. So that's going to be a positive 1x, or just a positive x, minus 3. And that's your finished answer. Right? It's pretty interesting. You can multiply 2 pieces times 2 pieces, and you end up with these 3 because you have like terms that need to be combined. And that's very important for you to remember, because we're going to be doing more with that when we go backwards. Okay, so let's try a few more just to make sure you're good. Okay, and what I'm going to expect you to show as far as your work is your area model. All right, so 2x plus 5 is my length. 4x minus 1 is my width. Split and split. And then we're just going to do each of the 4 pieces. So 4x times 2x and 4x times 5 and 2x times -1, or -1 times 2x, same thing, and -1 times 5. Okay, I'll write it out. That's a positive 20x, a negative 2x, and a negative 5. And then I'm going to combine my like terms. And I'm all done. And that's what I should see when you start on your assignment for this. All right, so let's try the next one. X plus 7 is my length. X minus 7 is my width. And again, you can swap them. It does not matter which one you put on the top and which one you put on the side. The length and width can be interchangeable as long as you multiply them. All right, so x times x, 7 times x, -7 times x, and -7 times 7. All right, so we have x squared. And again, that's a positive 7x there, right? Because we don't have to put a symbol there. A minus 7x and a minus, or a negative 49. Combine your like terms. And you've got x squared minus 49, because that is a zero pair. Very important. We're actually going to see that a lot later. Pretty cool that those two cancel out. All right, last one. Again, 2x plus 3 and 2x plus 3 again. So now we're multiplying two of the exact same thing. Okay, same deal. We're going to go ahead and multiply each of the four areas, because we have this part of the length times this part of the width, right? 4x squared. Okay, this part of the length times this part of the width, that's 6x. And then 3 times 2x, and then 3 times 3. Again, write down what we have so we don't miss anything. And then go through and combine our like terms. Okay, so there are a couple of challenges that I want to work through. A little bit higher level multiplying, which is fine. You will have a couple of these on the work that's going to be assigned for this, for the practice. But I just want to show you what they look like, because there's a couple of things, or a couple of times where we could go a little bit higher level than what we're doing. Okay, so something like this, very, very common as far as like a solving problem on your EOC, or an equation that you would end up solving. So PEMDAS tells us that we would do multiplication first, right? We can't do the parentheses, but we can do the multiplication. So you're doing 2x times x minus 4. There's my area model. And you're also doing 3x times 4x plus 7. Okay. And then you're going to add everything together when you're done as far as like terms. So we've got 2x squared, negative 8x, 12x squared, 3 times 4, and x times x, and then 21x. So then I just need to go through and put all my like terms together. And plus 21x. Okay, so I have 2 squareds. So that's 14x squared, 2 and 12. And then I have 2 regular x's. That's negative 8 plus 21, and that is 13. 13x. And so our answer is done. Okay, so take a look at the next one. You have 2 pieces here for the length and 3 pieces here for the width. Okay, so your area model is going to look just a little bit different. All right, it's going to be a little bit bigger. So if I have 2 pieces for the length, that's x minus 3, and then 3 pieces for the width, 2x squared and positive 6x and positive 2. All right, so now instead of having 4 boxes, because I'm not multiplying 2 and 2, now I should have 6 boxes, right? I've split the length into two pieces and the width into each individual term, right? And then I'm going to go through and multiply it the same way we normally would. You're just going to have to multiply 6 times and then go through and combine your like terms. So 2x squared times x. Okay, so this is that same thing I was telling you about earlier about like volume, right? This is 2x's that you've already multiplied. That's x squared times another one should now have 3x's. So that's x cubed or x to the third power. 2 and then one more, right? You add the exponents together. All right, 2x squared times negative 3. 6x times x. This is x times x, so I've got to have the squared in there. That's the second power. 6x times the negative 3. 2 times x, and 2 times negative 3. So write out everything you have. And again, I'm going across. It really doesn't actually matter if you do. You could also go down because you're eventually going to write all your pieces anyway and combine your like terms, so it doesn't really matter what order. Okay, so 2x cubed, I've only got one of those. This is just like what we did before with adding and subtracting. All right, so you go through your like terms. So now I have a negative 6x squared and a positive 6x squared. Well, that's a zero pair. I don't have to worry about them. They're gone. All right, I have a negative 18x and a positive 2x. Negative 18 and 2 is negative 16. And then the negative 6 does not have anything in common. Okay, so the last one, and again, this is something that you will see as far as like higher levels. You're basically multiplying three pieces, right? So this, you're going back to volume, right? Because length times width is area, right? And if I multiply length, width, and height, now I've got volume. Okay, so you cannot multiply all three of these at once. It just does not work. So what you need to do is find your area first, your length times your width. And after you've gotten that answer, your area, you're going to multiply that by the last piece. So basically what we did up here on this example, you're going to end up with your area, which will be three pieces, right? That's what we've seen, times your height, which is going to be like the two piece over here. So a little bit more steps, again, a little bit higher level. I know you can do it, but I just want to give you an example so that when you see it, you don't panic and be like, oh, I've never done this before. Okay, well, we have. It's just like multiplying area and then volume to go start up. So x times x, okay, x times negative 1, 4 times x, and 4 times negative 1. All right, so go through and combine your like terms right there in the middle, right? So x squared plus 3x minus 4. Okay, so now we need to make another area model, right? Because this is now our area, and you can put it either way you like. So x squared plus 3x minus 4. I'll put it across, and then I'll do the 2x plus 5 going down. Again, you're doing the exact same thing. You're just doing this more because you have to split it into the individual terms in order to be able to multiply it and not leave anything out. Okay, so let's go ahead and finish and get our volume. So we have 2x times x squared, same thing as before, and x times something that's basically already an x times an x gives me 3 of them, right? 2x times 3x, we have the 6 for the coefficients and a squared for the x's. 2x times negative 4. 5 times x squared. 5 times 3x. And 5 times negative 4. Again, write it out. Going across or down does not matter. Ooh, I'm going to run out of room just a little bit. Slide that over. All right, and then minus 20, and then go through and combine all your like terms. So, that's supposed to be a cubed. So, got 2x cubed to the third power, right? That's our first piece. And then I have a 6x squared and a 5x squared. Remember, like terms have to match. as far as variables and exponents. So that's 11x squared, because I'm just adding them now. And notice the variable didn't change when you combine your like terms together, right? Just like when we're doing adding and subtracting, we don't change those because you're not multiplying them. They're not getting bigger. You're just adding them together. All right, so then we have negative 8x and positive 15x, positive 7x, and then the negative 20 stays by itself. And then we're finished, and we have, basically this would be a volume. Okay, so you can go ahead and start your assignment for this, and I will talk to you later.